welcome to the session. Today we will discuss another topic which is defective chessboard, which is also another application of DNC strategy. So defective, in today's lecture we are going to cover the problem statement of defective chessboard, and also we will see the example, and also we will see the algorithm followed by analysis part. Now, the main objective of today's lecture is the students are able to understand the concept of defective chessboard outcome. The outcome is today they are going to acquire the knowledge on how to apply the defective chessboard algorithm on a given chessboard. Now, what is a problem statement? So, before going to that, what are the given conditions? So, we have a chessboard size of n by n, where n is equal to 2 to the power of k, and here in the given chessboard exactly we will be having only one defective square, and here we are going to find out the position of defective square, right. So, basing on the trinomials, so here we are going to paint or we are going to trace the defective square by making the trinomials. In trimino means L-shaped one is a trimino which have 3 squares. Now, the main objective is cover all the chessboards with L-shaped tiles except the defective square, so that I can find the solution. So, now how to solve this, how to get this? So, here I need to make the triminos in the adjacent corners of the defective square, and by making that, here I need to find out the defective square position, right. So, now absolutely it is possible to cover all the non-defective squares. Let us see how. As the size of chessboard is n by n and n is equal to 2 to the power of k. Now, the total number of squares. What are the total number of squares? 2 power k into 2 power k. Why? Because n by n is a size and n is equal to 2 to the power of k. In powers of 2 I will be having, right. So, 2 to the power of k into 2 to the power of k means 2 to the power of 2k are the total number of squares in the given chessboard, and out of that only I have one single defective square. So, now except the defective square, what are the remaining number of squares which are not defective? 2 power 2k minus 1. So, now for the value of k, 2 to the power of 2k minus 1, for example, k is equal to 1. Let us take k is equal to 1. K is equal to 1 means, so here this 2 to the power of 2k minus 1, k is equal to 1. So, 2 power 2 minus 1, which is 4 minus 1, which is 3. So, this value is 3. When k is equal to 2, so 2 to the power of 2 into 2, which is 2 to the power of 4 minus 1. Right, 2 into 2 which is 4, 2 to the power of 4, 2 to the power of 4 means 16 minus 1 which is 15, 16 minus 1 which is 15. So, 3 and 15 all are divided by 3. So, 2 to the power of 2k minus 1 is divisible by 3. So, by using this phenomena we are going to find out the solution. Now, this is a 1 by 1 chessboard, and here we are showing the image of initially the first image corresponding to 1 by 1 chessboard, and this itself is a defective. Now, when I am taking for 2 by 2, so these are all for 2 by 2, these are all for 2 by 2, and this is for 1 by 1. So, 2 by 2. So, if I am having a defective over here, this makes my trimino, and if this is a defective and this is my trimino, and if this is a defective and this is my trimino, and if this is a defective and this is my trimino, which is covering the edges of the corresponding defective square. Now, for k is equal to 0, so here 2 power 2k minus 1 which is 2 power 0 minus 1 which yields as 0. So, the 1 square, here 2 power 0 means it is equal to 0, right. The 1 square itself is defective. For k is equal to 1, 3. So, as the size of these chessboards are displayed here, 1 by 1, 2 by 2, we do not have to place any L-shaped tile in the first and rest can be filled by using the L-shaped triminos. Now, coming to 4 by 4, let us take 4 by 4 chessboard. So, let us consider here I am having the defective square. So, here initially I need to trace out by making the triminos, right. So, it is going to cover even this trimino, even this trimino or this trimino. So, here in this example I have taken this trimino which is going to cover the two edges of the defective square, and now from there I am taking the next bottom one, and next this one, and next this one. So likewise I am going to take all the trimenos which are going to be covered in the defective chessboard, which is of 4 by 4 size. So finally I am showing you with each and every color over here. So here this is one trimino, and this is another trimino, and this is another trimino, and this is another trimino. Likewise each and every trimino I am showing you with color, different color. Now let us take 8 by 8 chessboard. So first let us consider here any of the chessboard, only one square is defective. So please remember. So now step 1, one of the cell is defective. So that defective is I have shown with this black color. And now we are going to divide the chessboard into equal sub halves, which is here into 4 parts. Why 4 means 8 by 8. So if I am dividing it into 8 by 4, it will not make it into a clear cut problem. Why? Because there is n by n chessboard, not n by m chessboard. I am having n by n chessboard. So that is the reason I am making into 4 halves, so that each and individual one will be remain again into 4 by 4, again 4 by 4, again 4 by 4. So I will be having 4 by 4 chessboards out of 8 by 8. Now trick is to cover the chessboard with tiles. So now here the corner, okay, the middle corner, which, okay, here is a middle one. Here I have to insert one defective box, or one, okay, I have to cover this middle corner with a trimino now. Now again I have to cover all the triminos, okay, I have to cover all the triminos which are edges to the defective square. So likewise here whatever I am showing you in a grey color, those are all the triminos in the sub problems. Now as we have finally divided the problem into 2 by 2 board, now after covering the triminos into the 4 by 4 sub problem, now even that 4 by 4 again it has to be divided into 2 by 2. Now again it is divided into 2 by 2. Now let us consider here is our defective square. So this will be colored in yellow color. Now again this will be, again this, again this. So likewise even here also this will be covered. This will be covered with one color, and this will be covered with another color. So likewise, so even whenever I am solving this, here this has to be covered in one color, and this has to be covered in another color, and this has to be covered in another color. So likewise I need to color, okay, with the different colors for all the triminos. So now step 6, the procedure will continue until all the subboards are covered with the tiles. So now here is the final solution. So combining of all the sub problems. So initially 8 by 8 it is given to you, and that is divided into 4 by 4. First it is getting divided into 4 by 4 chessboards. Again each and every 4 by 4 is getting divided into 4 2 by 2 chessboards. And again that each and every 2 by 2 is getting divided into again 1 by 1 chessboard. Here is the solution. Here if you have seen here the total 8 by 8 chessboard is being divided into 4 by 4 chessboards, and each and every 4 by 4 again they are getting solved by using DNC strategy. Now again here the 4 by 4 chessboard from the 8 by 8, right. So this one again it is getting solved by taking 2 by 2. So here this part will be taken, and 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 individually for the 1 by 1 or 2 by 2 the direct solution can be returned, as we have seen, which is a base case in the problem description itself. So like we are going to like find the solution for the defective chessboard. So this is for 1 by 1, 2 by 2, and 4 by 4, and 8 by 8. Now this is the algorithm for defective chessboard. So here top R and top C, which is a row value and column value of the starting indices, and defect R and defect C, which are the positions of defective row, and which is the position of defective square, and the size is nothing but size of the chessboard. If the size is equal to 1, which means that 1 by 1 chessboard, so simply written, which means that we itself it is a defective square. Now otherwise we have to increase the tile plus and we have to make the quad size to size by 2, because when there is 8 by 8 we are making into 4 by 4, nothing but we are dividing our chessboard into 4 by 4 for 4 by 4 quadrants, right. So likewise here we are performing, that is why it is size by 2. So if defect R is less than top R plus quad size, and if this condition is evaluates to true, then the defect is in this quadrant. So please remember, if this condition is evaluates to true, if this condition evaluates to true, then simply we can conclude that the defect is in this quadrant. Now, so for that reason, again we are calling this function with top R and top C, defect or defect C, and now quad size gets changed. Here initially it is a size, but now we are calling this function with quadrant size. Now else means no defect in that particular corner, so simply I have to consider another quadrant. So the same thing procedure will be, okay, the same procedure has to be repeated for all the remaining quadrants also, and this algorithm is shown for 8x8 chessboard. So this is for first quadrant, and the 8x8 chessboard has to be divided into 4 4x4 chessboards, right? So now this code is remaining for remaining 3 quadrants. The quadrants means here remaining 3 4x4 chessboards. And now tiling one of the 4 smaller boards corresponding to tiling the defective 2 to the power of k minus 1 into 2 to the power of k minus 1 chessboard. So now to convert the remaining chessboards to defective chessboards, we have to place a trimino at the corner, right? So here we are placing a trimino in the corner part, and by making that we are going to find out the position. Now here each time the number of tiles needed to tile the defective chessboard is psi square minus 1 by 3, which is 2 power 2k minus 1 by 3. Now if k is equal to 1, which is equal to 1, if k is equal to 2, which is equal to 3. So to tile the defective chessboard, which is always divisible by 3, as we have seen 2 power 2k minus 1 is divisible by 3. For k is equal to 1, which is equal to 3, and for k is equal to 2, the 2 power 2k minus 1 is equal to 15, which is divisible by 3. So we have to remember that which is always divisible by 3. So now let T of n denote the time taken for a defective chessboard, which is for the tile board algorithm to tile a 2k by 2k defective chessboard. So now the recurrence relation for this is given as 4t of n minus 1 when k is greater than 0, and which is equal to d when k is equal to 0. Why? Because here 4 times the recursive call is made, because in each and every quadrant we are making a call to the tile board algorithm. That's why it is 4t of n minus 1 plus c. So now we have to solve this by using substitution method. So here t of n is equal to 4t of n minus 1 plus c. So now here the sub problem which we don't know is 4t of n minus 1. So this t of n minus 1 is again we have to substitute by using substitution method. Again we have to substitute this n minus 1 in the given equation, which is 4t of n minus 1 minus 1 plus c, which is 4t of n minus 2 plus c. Now I have to substitute this 4t of n minus 2 in t of n minus 1. So now this modified t of n minus 1 is 4 square into t of n minus 2 plus 4c plus c. So in the same manner I am going to substitute again. Here I will be having 4 to the power of n into t of n minus n plus 4 to the power of n minus 1 into c plus 4 to the power of n minus 2 into c plus so on plus c. So finally it will be 4 to the power of n into t of 0 plus so on plus 4 to the power of n minus 1 plus 4 to the power of n minus 2 plus c. So if I am taking c into common, so 4 to the power of n minus 1, 4 to the power of n minus 1 plus 4 to the power of n minus 2 plus so on 4 to the power of 0, right. So together I can write it as theta of 4 to the power of n. So here the highest term is 4 to the power of n. So that's why we have to take 4 to the power of n only. So the complexity is 4 to the power of n for defective chessboard. So coming to the summary, today we have seen what is the problem statement of defective chessboard, and also we have seen the algorithm, and also we have seen the analysis part. Now this is a small exercise. Consider an 8x8 chessboard with a defective position 0, 3 and show the tiling obtained by using different colors. You can use sketches or whatever you are comfortable. Thank you.